Okay, we're off to the afternoon, and this is a super easy introduction. Vint.
Wow. Well, thank you very much. People shouldn't clap before you've said anything because you tend to want to sit down. It won't get any better than that. And I have to explain to you the only reason I'm up here is that I tried to support this operation and they promised to give me a little time to sermonize, so you've got to listen to the chief internet evangelist for a little while. The thing I wanted to talk about is the challenges and opportunities in online interactive systems. And I don't know whether very many of you experienced the NLS the way I did, because when I was at UCLA working with Steve Crocker, who's in the room here somewhere, and the inventor of the Request for Comment series, we made heavy use of NLS to compose RFCs in the early stages. But we were down at UCLA, and of course the NLS system was up here. And I ended up using a Texas Instruments Silent 700 thermo printer to do my NLS documents. This is not the same as being able to point at things with a mouse. There wasn't any mouse associated with that. So we had to use a rather different kind of interaction. Incredibly, it worked, which tells you something about how powerful the NLS system was and adaptable that it was, even working in this almost line-at-a-time mode. And there were some hints about that adaptation when you heard Jeff Rudolphson and his group up here. So I just wanted to tell you that that was my experience with this. The other thing which I think is very important is that SRI was the second of the nodes up on the ARPANET, and it was there because of Doug's network information system. And Jake Feinler, who's also here, ran that operation forever. So Jake was really the net mom for ARPANET and internet documentation, among other things. And so it was very important that ARPA chose to put the network measurement node up at UCLA and the network information node up as the first two nodes on the ARPANET. There were some wonderful analogies that I heard in the last couple of days. Yesterday, I spent the entire day with people who are out there doing demos. And I'm going to share a few of the reactions I've had to them with you, hoping that they might be of interest. But there was this comment earlier about augmentation and de-augmentation. So the example of de-augmentation was tying a brick to a pencil and then trying to write with that. That's definitely de-augmenting. The interesting idea about augmentation was sort of attaching a computer to a pencil, which is kind of what the NLS did. It basically transformed the nature of writing and reading. And the point that was made earlier about those two things being, of course, two sides of the same coin is very important, and that we may have lost the production side while we've been so busy on the consumption side. So as I spent the day yesterday with these very creative and inventive people, it sort of dawned on me that they were like artists who had found a new palette for expressing information. And so if you think of an artist with a palette with lots of different colors and mixing those things together and producing a painting, these people are painting in a conceptual space that's much, much deeper than the kind of flat text that we've been accustomed to ever since the invention of the printing press, or writing for that matter. And so I think of what's going on by tying or attaching the computer to the pencil as creating an expressive space which is deeper and has more dimensionality than we've ever had before. And much of what's going on out there is making it easier and easier to explore that space, to express in that space. I remember, I wasn't at the 68 demo, but I saw, of course, the films that were taken of it. And the thing that really struck me more than anything was this picture of Doug hardly moving at all, and the screen is going crazy because there were very small little economic instructions that he could issue but cause major changes to be made to what was being shown on the screen. And the same sort of thing was going on with what the folks who are doing demos have done, is to take extreme parsimonious ways of asking the system to do things to the content that they're either producing or manipulating or exploring. And so this is, from my point of view, this removal of friction from the ability to produce content and to present it is what I consider to be among the most important technical contributions that we're seeing today. Now, this is not intended to diminish in any way Doug's much broader hope that those tools would end up being used by groups to learn to collaborate effectively. And so yesterday I was thinking about that and thinking that what Doug was trying to do is to reduce the friction in collaboration, to make the collaboration much more liquid and frictionless. And I think that's a place where we still have plenty of work to do. I also began to think a little bit about real-time collaboration. We have a small bit of that at Google, in Google Docs. And I didn't really appreciate the power of collaborative interaction, even just in text or a spreadsheet or shared documents. I've had now regularly groups of people, perhaps 3, 4, or 5 people, with the same document open at the same time, but physically remote from each other, possibly with a video conference in addition to the document, sometimes just voice. But the fact is that we can all see the same document. We can alter the document in real time. We can see the results of the alteration. So one little anecdote, I remember being given half an hour to produce some sort of a statement for publication. And I needed the legal team to make sure I didn't say something, stupid. And so several of us got onto a Google Doc, and somebody would type something, and somebody else would say, no, that's a dumb idea for the following reasons, and they'd change the text. Within just a few minutes, we were able to settle on something. We could not have done that even if we had been sitting around the same table fighting over a piece of paper. And so that's the sort of enabling character that I think the tools have. And so I am a big believer that the tools are extremely important, although using them is even more important. So this real-time stuff is really cool. Now, I have to give you another example of the unexpected consequences of real-time interaction. I remember sitting next to John Postel at SRI. We were having a meeting. John was using the GE light valve, which is the thing that I think was used to project images up in the 1968 demo. And if that's wrong, somebody will correct me. But the light valve was a projection device in very early days. And so John had this image on the wall, and he was taking notes. And he was taking almost verbatim notes. And so I was talking, and while I was talking, what I was saying was coming up on the screen, and I stopped talking to wait to see what I was going to say next. And, this sort of a weird feeling. So that tells you something about what the real-time interactions are like. But there's something else going on that's perhaps even more important, and that's long-term interaction. And I was, in fact, when you think about writing, when you think about capturing things in documents, in a way, it's an opportunity to have a conversation with the future. It's true that you don't get to hear what they had to say, but you can speak to the future if those documents are still available to your descendants. And so I think it's important for us to remember that we can have both of those kinds of conversations, even though one of them tends to be one way. I think also, oh yes, now speaking of this long-term kind of collaboration, I remember a meeting with John McCarthy and several others at Carnegie Mellon, probably around 1988 maybe. I was working at CNRI with Bob Kahn, and we were focused on digital libraries and information infrastructure and how we could use the internet. This is pre-web. And so we're talking about what could we do if we had digital libraries. And John McCarthy said, you know, 100 years from now, people are going to say, did you know that 100 years ago we had books that didn't talk to each other? And if you think a little bit about the kinds of objects that are being created now that have this, that are embodied in an online environment that sometimes have active software in them, that the possibility of these things literally interacting with each other and possibly morphing over time in consequence of new content showing up is not a crazy idea. And it breathes life into information which historically has tended to be pretty static. So even the web today is relatively static. When you think of a web page, it's true, it could have software in it, and it could be animated, but the basic structure is fairly static. But as you start thinking about people working together, contributing over time, think of Wikipedia, for instance, the dynamics can start to appear, especially if they're self-updating. If they're, imagine documents that are searching the web for relevant content that they should refer to and discovering this on their own. I'm sure there are all kinds of silly, maybe a dumbass idea, but you kind of get the idea of this dynamics that are possible. I wanted to mention something else, and that's the power of demonstrations in general. And I particularly want to draw attention to the fact that ARPA has become extraordinarily skilled at picking demonstrations to cause things to happen. So as an example, the first, this is the 1968 demo, is an example of something that ARPA, I should be careful, at the time, pushed for, because people could see something real and concrete as opposed to purely speculative. In 1972, the ARPANET was demonstrated publicly for the first time at the International Conference on Computer Communication in October of 1972 in the basement of the Washington Hilton Hotel. We put in an ARPANET imp, a tip, actually, and then we had a bunch of teams there to demonstrate various applications on the ARPANET. And Bob Metcalf, whom all of you remember was the co-inventor of the Ethernet, along with Dave Boggs at Xerox PARC, was doing some demonstrations. And he tells stories about AT&T showing up for a demo of packet switching and its power. And of course, they don't believe it works. And Metcalf was demonstrating a particular application, and the net died right in the middle. And the AT&T guys got a big smile and walked off saying, yeah, we said it would never work. Well, so much for that theory. There are a couple of other examples of demonstrations that were of considerable importance. One, which took place in 1976 here in the Bay Area at Rosati's. The Packet Mobile Radio Van, which was built by SRI International to help demonstrate and test the packet radio net, went up to Rosati's for a beer, and they demonstrated a connection from a terminal at that van through a gateway. We didn't know they were supposed to be called routers, through a gateway into the ARPANET. That was the first two-network internet demonstration. And then a year later, in November 22nd, 1977, while I was at ARPA running the internet program, I asked for a three-network demonstration. So we had the packet radio net, the packet satellite net, and the ARPANET all linked together with packets going from the mobile radio van all the way to Europe and all the way back again to USC, Information Sciences Institute in Los Angeles. The packets only went 400 miles geographically, but they went 100,000 miles up and down through two satellite links and back and forth across the Atlantic in the United States. And it worked. And I remember leaping around in my office saying, it works, you know, like as if it couldn't possibly have worked. Listen, it's software, and it's a miracle when software works, so. I'm not called the chief internet evangelist for nothing. Not only do I believe in miracles, but I rely on them. And in 2004, ARPA asked for people to demonstrate self-driving vehicles. 2004, of course, it didn't work very well the first time. Second time, 7 of the vehicles made it all the way to the end of the course, and of course, many, many things have happened since then. up till the present where we're starting to see commercial services. So demonstrations are often a very powerful way of making believers of people because they can actually see something work. And I think it's quite extraordinary how convincing it can be when you actually see something work as opposed to speculating about it. Now, having talked about all this, I hope that you recognize that we have some extraordinary challenges ahead. After we have gone, from things like vellum, a lot of sheep and calves die for you to create documents. Those things lasted 1,000 years. And many of you know I have this rant, which I won't bore you with, about the fact that all of our technologies over time have gotten shorter and shorter lifetimes until we finally get to the spectacular, beautiful, and wonderful digital media, which lasts for a decade or two if we're lucky. And even if the medium lasts, the readers may not. And so, how many people have 5¼ floppy disk drives that they're sitting around gathering dust and no reader for them unless you go to the Smithsonian. So the point I want to make here is that the power of what you're seeing in the demos, the power of what you saw in Doug Engelbart's demo, is in some ways eroded by the possibility that the objects that are created in this digital form may not survive because so much infrastructure has to be in place for them to be understood, interacted with, read, or edited, modified, or and the like. So we need to think really hard about how to create persistence for those digital objects to maintain their utility over time. And look, our predecessors have documents that lasted 1,000 or 2,000 years. We're nowhere close to anything like that in our space. And so I think we have a huge challenge ahead of us. Either that or the future will not know anything about us in their past. This thing says 0, so I assume I'll be thrown away as soon as our moderator tells me I should go away. But I have a couple of other things I'd like to. I think that the demos are good for igniting imagination, but it's not the same as operational. And so there also is a big issue getting from demo to something which is practical and sustainable. And so there's another big issue. Sometimes the sustainability has less to do with the technology than it does the economic business model or the possibility of changing people's attitudes and willingness to use different kinds of tools. So getting from demo to practical is also a very significant challenge. Now, the other thing I wanted to draw to your attention is that as we explore some of these online means of creating and interacting with content, that we need to remember that not everyone has the same capacity to interact with these things. If you happen to be blind, or you have low vision, or you're deaf like I am, or you have mobility problems, that we need to think really hard about how to take these new technologies and make them fully accessible for everybody. Now, some people will look at that and they're sort of dismissive and they'll say, well, too bad if somebody who's blind can't see this. The problem that I would like to point out is that as you get older, and I'm learning what this is like, sometimes you experience some disabilities that you didn't have and didn't even care about when you were younger. Or you may experience temporary disabilities, and sometimes I think that's the most important experience for people to have. Break a leg and spend 6 weeks in a wheelchair, you will discover what life is like for people who are permanently moored in a wheelchair. Or break an arm and discover that keyboards are really hard to use when you have only one hand to use them. So accessibility and usability, I think, are important, and we should not get so carried away with the wonderful and rich experiences we can create with computer-aided information that we forget that we need to make it fully accessible to everyone. That's a huge design challenge. This is not sprinkling pixie dust on the code to make it accessible. This is thinking through, how will I make this application usable for people with a wide range of challenges? And so I hope that the folks who are exploring these advances beyond where even Doug had implemented, not thinking, but not where he thought, but where he was able to implement, that they keep that in mind as well. So I think I really, it's only one other point, and then I'll get out of your hair. Think for just a minute about some of the panels that you heard, especially the one that Brewster Kahle and Tim Berners-Lee and Tim O'Reilly were on, thinking about the rich information environment that I took away from their discussion. And I'm thinking, how do we curate that? Because the medium does not confer veracity on anything. We can print fiction just as well as we can print truth. We can express these in these media. The medium is not going to help us very much. We also have one other problem, which I'll finish with so that you can get on with it. You remember the Turing test? You remember how that worked? The Turing had a human being interrogating a person in a computer. And the task was for the person to figure out which one was the computer and which was the human. And if the computer succeeded in fooling the interrogator, then the computer passed the Turing test because it was not distinguishable from being a human. Now there's Turing test 2. What is that? That's a computer interacting with a human and a computer. And the test is, can the computer figure out which is the human and which is the computer? And if the computer can't figure out which is which, then it's failed Turing test 2. And that's the problem we have. We can't tell a bot from a human right now. That is polluting our information environment. It is creating an asymmetry, which a small number of people can use to influence and pollute our information atmosphere. That's a problem we have to deal with, and it is not going to admit of a purely technical solution. So there you are, plenty of challenges ahead, lots more work to do. And for the young people, 50 years from now, you'll be meeting here saying, we figured that one out. Thanks.
I have one observation and a question for you. The observation is there's a Turing test 3.
What's
and
that?
The Turing test is when we have machines that consistently pass the Turing test, we're going to discover what percentage of the human population fails the Turing test. And in this particular moment in time, I fear it may be very high. As I think about the future you're painting, I think I have a metric for it. How many miles do you fly per year in airplanes?
Let me make sure that we express this correctly. I am flown in the air. I don't fly the airplane, but the answer is...
He got here and boy, are his arms tired. Yes.
Look, I'm an engineer. I'm literal-minded.
So you're self-floating...
About 300,000 miles.
About 300,000. So I would call that's an indicator, and I would put a name on it. Let's call it the Vindicator. That the year you stand up on this stage and you say, I haven't been on a plane in 12 months, we know the future's arrived.
Wow. So let me tell you the benefit of all that travel. My wife and I just celebrated our 52nd wedding anniversary in September. But I travel about 80% of my time. What that means is we've only been married about 10 years on the average. And that works. Thank you.
Thank you, sir.